Hello, Cnbt 1342. We are live again. This is the video for week 3, exam 3. If you've been following the directions that I've given you, you will have printed out your exam as we go through this video, as we've done in the past. All right. Another one of my OCD pet peeves here. 231. All right, so let's get started. Accessibility. All right, this is dealing with ADA, American Disabilities Act. This is not going to make you an expert. You can download the entire ADA code from the United States government online and check with your local authorities. Okay? So let's get through this. Everybody knows what this is. It's a handicap deal. Now we know there's a difference. We've discussed this before about ADA compliant and ADA accessible. There is a difference. All right. If you go to work for a larger firm, you may be put in the ADA section of y'all's designs, depending on what you actually do. All right. Oh, let's get on down here. All of this you can read on your own about wheelchair turnaround, doorways, stuff like that. When I remodeled my kitchen, I mean my bathroom, I made sure that the doorways were ADA width and everything else, so I could get a wheelchair in there and a walker. Didn't need a wheelchair, but I did need a walker with both my knee replacements and my back operation. All right, so our first salient point, what this talks about, the accessible route for an ADA entrance and exit to a building. Okay. What is an accessible route? The definition is in here. Okay, the definition is in there. All right. It's basically the ADA entrance and exit route. Right? From the parking to any ramps, any slope surfaces, public transportation, or the entrance to a building, and then obviously the exit to that building. All right. What's the minimum slope of the ramp? Minimum slope again is a pitch of 1 in 20. Ramps having a slope of 1 in 12 and shallower and complying with the technical requirements of this are acceptable for use as acceptable routes. A slope surface with a pitch of 1 in 20 and shallower is not considered a ramp. It is acceptable to use such slopes in accessible routes if level landing areas are provided at doors or changes in direction as required by that code. Okay. So a 1 in 20 is not considered a ramp. It's a slope. Let's go to the dwelling types. Dwelling types. You have a Class A dwelling unit and a Class B dwelling unit. Class Type A, it says up here, are adaptable units built as ADA. And a type B dwelling is a wheelchair friendly, but it's not necessarily accessible. There's a big difference. You look at the type B in the Fair Housing Act and a type A in the Fair Housing Act and read this. All right. How about motor vehicle facilities? Now, these sections in here talk about what you must do for access and egress. We've seen these diagrams before. All right. If it's a portable tent structure, and have to be dealt with ADA also. Plywood decking so the wheelchairs can get in and out of the temporary facilities. Okay. This talks more about accessible routes. Like I said, the ADA is a lot more intensive than just this, but this all goes back to sections of codes that you as a designer may or may not have to deal with at some point in your design career. Parking is another deal. Civil engineers, you'll work with your civil engineers and your planners to make sure that the proper handicap parking is done and the number of handicap parking units. All right. Motor vehicle related facilities. Motor vehicle related facilities, and that includes the greeny-weeny boondoggle EVs, electric vehicles, and electric vehicle charging stations. Yes, they must be ADA accessibility. Yes, they must be. How about toilet facilities? Well, we already know, unless you've been living on the dark side of the moon, yes, toilet facilities must be ADA compliant. Now, dwelling units and sleeping units. This talks about the grades and the slopes of the grades and how you got to handle that. So maybe these units up here may not be suitable. So maybe these units down here are more suitable. Obviously, this one would be the most suitable, right? Because it's flat. This might not be such a good idea, this area up in here. And again, it talks about the slopes and the grades and such as that. Seating area. We've talked about hearing impaired, visually impaired in the past. All right, let's get down here to the next major deal that we want to point out in this chapter. All right, toilet facilities. All right, do they have to be accessible? Well, the answer is yes. They've got to be accessible. You want to have a civil rights violation and violate the Fair Housing Act and your local codes. Your local codes are going to vary also. All right. You'll find if you've been living on the dark side of the moon, or you haven't been, I mean, most of the ADA toilets are at the very dead end of the restroom. Okay. What percentage of sinks must be accessible? Well, 5% of the sinks must be accessible. This section requires accessible space for rooms and kitchenettes must be acceptable. How about drinking fountains? 50% of the drinking fountains. 50% of the drinking fountains. 5% for sinks, 50% for drinking fountains. Okay. What about bottle filling stations? They must be accessible also, right? So why would you not have a sink, a watering station, hydration station, drinking fountains, Okay, you'll find that most good designers will have the bottle filling station at the wheelchair accessible drinking station. It just makes sense. It's economically feasible. A non-wheelchair person can certainly fill their bottle at one of these. You'll see the differential in height is anywhere from 38 to 43 inches for the non-wheelchair bound standing access, and 36-inch maximum for the wheelchair access. Okay, so it just makes sense, right? All right. All right. And we're going to finish off chapter 11. Like I said, we're not going to turn you into an ADA expert. You may do that in your future. The ADA code is much more intensive than what we've seen here. Elevators, we talked about elevator access in CNBT 1311, and I think earlier in this one also. Lifts, if you have to have stairs and there's no elevators, there must be a wheelchair lift for the stairs. All right. And what do you do with these in a fire? Well, you need to check with your fire code and find out how you're going to handle this. All right. If you've got wheelchair-bound people on your upper floors, there must be a way to get them safely extracted. Okay. Storage facilities, medicine cabinets are provided. Requires that 5% or at least one in each type of storage be accessible. So you have lifts. It deals with storage. A good idea is if you've got the real estate, I would just make everything accessible. It's just easy on everybody. If I ever get to design a house from start to finish, trust me, the whole bloody thing is going to be ADA accessible and compliant. I'm almost 70 years old, and who knows, I might need that. Like I said, when I remodeled the bathroom years ago, I made bloody sure we could get a walker and a wheelchair in there. All right. And this talks about detectable warnings. We talked about this before in a previous video. Signage. This is signage with Braille. And then other signs for accessible listening devices, right? All right. Signage is regulated under the accessibility codes. We all know that. That's also required. And proper signage. All right. And then there's appendices and everything else for the rest of this. All right. That pretty much covers chapter 11. Let's go on to chapter 12, the interior environment. All right, the interior environment deals with ventilation, ASHRAE, your local codes, and it's for health and safety, and how airtight the building is. Blower door testing or air leakage is required these days. It's an important part of the building process as it determines the overall air tightness of a building and helps to identify problematic leaks that may be present. Now, you don't want your building too bloody tight because you'll be living in an igloo cooler. And if it is tight, then you've got to have forced ventilation and air changes in there. Okay. As a result, it's been required for all new construction and additions since 2015. The IECC was released. Blower door test by Matt Riesler is a good YouTube video, and I expect you to link this. It is also in your video list under this chapter. Go to it. It's a short video. It goes through and talks about an air test on a house in Austin that he's doing. Now, Matt Riesler has a great YouTube channel. I suggest if you're into architectural design that you subscribe to Matt Riesler. If you've been in my CNBT 13 14 class, there are a lot of videos. He does a lot of energy efficient buildings and houses and remodeling, goes through what he did, the mistakes he's made, and such as that. But the blower door test is extremely important, okay, these days. Now, my 50-year-old house, they didn't even know what a blower door test was back then. All right. Building ventilation and air movement is what, okay, building ventilation. What is in ventilation? Building ventilation. It's the air movement in and out of the structure, both in the concealed spaces and in the livable spaces. All right. It's got to have a balance between the moisture generated from our exhalation and inhalations. It deals with the health and safety of humans inside the building. Okay? All right. Okay. All right, this page talks about the blower door test. Okay. Exhaust fan is required if air infiltration rate is measured at less than 5 air changes per hour due to the blower door test. The blower door with a fan gauges the pressure differential between the houses. I mean, inside the house. All right. You got attic leaks, you got window leaks, you got wall system leaks. If you got penetrations through here, those produce leaks and that sort of thing. All right. So the maximum blower door test air changes per hour under the IECC, the International Energy Conservation Code, the maximum is 5. The maximum is 5. You can find that over here. And over here. Okay. The IECC typically does not permit a house to have more than 5 air changes per hour. So if it is adopted by your local authorities, mechanical ventilation will typically be mandated as houses become more energy efficient and thus more airtight. It will become more likely that blower door tests will be required. Now, for the most part, they are. All right. Oh, God. If a house after the blower door test has more than 5 air changes per hour, can natural ventilation be used? Well, the answer to that is yes. Okay. All right. If a house after the blower door test shows that you have more than 5 air changes per hour, you can use natural ventilation to offset that. All right, let's go to vent louvers. This is a vent louver, ventilation louver. Okay. All right. What is the free area of a vent louver? Of the area vent louvers adopted, okay, covered with screens, all right, attic spaces, vent openings be provided, all right. The net cross-sectional area is permitted to reduce 1/3 of the 1/300ths, okay. So, good rule of thumb. Vent louvers at vent openings to assume 50% of the free area. You need to consult your manufacturer's requirements for the vent louver. They'll tell you what the free area is. The free area is the amount of space allowing the actual airflow. The free area is the amount of space allowing actual airflow through the vent. And the manufacturers will have all their vent louvers tested and will tell you vent louver A has X amount of free area. It's the amount of space that air is allowed to flow through the vent louver. Okay? In other words, in section, if this is the vent louver, and there are the vents, keeps the rain out, blah, blah, blah. Okay. This whole cross-sectional area, if we're looking at it in sort of an ISO gizmo, and it's a pretty bad drawing. I'm an engineer, I'm not a draftsman. Okay. Is the amount of area that you can get X CFM through this in a natural airflow. And your manufacturers will test all of that. Okay? All right. All right. Good rule of thumb is what again? I said a good rule of thumb is 50%. A good rule of thumb for louvers and vent openings is to assume 50% of the free area. So if you did a triangular area here, the area is the 1/2 the base times the height. If you remember your simple geometry, you can assume 50% of that. I would consult the manufacturer's data because these are going to be also screened, and that will impede the amount of free airflow through the thing. All right. Now let's go down to crawl spaces. You read through all this, talks about temperature differentials and stuff like that. Let's look at crawl spaces. Vents for crawl spaces. Vents for crawl spaces. This is just a natural flow, convection of air. Okay, soil is going to be cooler than the enclosed space up here. All right. Well, what is it? Vents for crawl spaces with uncovered earth floors are to have a net free area of at least 1 square feet for every 150 square feet of crawl space. Matt Riesler has some good videos of some houses he did in Austin that have crawl spaces underneath them. He likes to put a mud slab in here. That's concrete, and I agree with him. So he basically builds a little bitty basement, raises the house above that, and sometimes he'll even have a certain percentage of the air conditioning and heating in that crawl space. Subscribe to his channel, and you'll learn a lot. He's pretty innovative, architect, builder. He's done some neat stuff. How to take an existing old house and make the roof and walls a lot more energy efficient. Enough for that. Okay. All right. So go back up here again. Just normal convection. It's 1 square feet for every 150 square feet. You should not have a problem answering that question. All right. Natural ventilation. I'm a big proponent for natural ventilation. You don't see a lot of attic fans anymore in houses. That's too bad. I'm a big proponent for those. If I ever design a house, I will have an attic fan. That's just a fan that is well, it's about the ugliest looking fan I've ever seen. Anyway, it's a fan with louvers, and when you kick the fan on, the louvers open up, and it sucks air through all the windows and then out through gabled louvered vents or out through a ridge vent, assuming you have enough ventilation area up here to get the volume of air that you're trying to exchange out of the house in there. It's a great way of taking the ambient temperature out here and exchanging the air in a residence in very quickly. And then you can turn it off once the temperature in here equals the temperature outside, and then turn your HVAC back on. Let's say you got a nice spring norther come in, and it's 68 degrees out here, and it's 80 in the house. Well, open the windows, turn on the attic fan, and in about 10 minutes, the entire house will have fresh air in it, and it will be the same temperature as the outside. And then close the windows and turn your AC back on, or leave it running. Whole house ventilation. I'm a big proponent for that. All right, let's go to, this is a no-brainer. Do toilet facilities have to have ventilation? Yes. If you took my Cnbt class, you'll know what my pet peeve is about the normal air exchanges in a kitchen and the normal air exchanges in a bathroom. I doubled the minimum requirement when I remodeled my bathroom and put an exhaust fan in there so I could get twice the number of air exchanges out. We live in a very humid and very hot environment. So in all cases, code requires mechanical ventilation of rooms containing bathtubs, showers, spas, etc., etc. Now, my 50-year-old house, the upstairs bathroom does not have a mechanical ventilation. So when we redid the windows, the bozo salesman said, well, we could just do fixed windows up here. And I said, no, you will not. We don't have mechanical ventilation in that small upstairs bathroom. So the square footage area of that bathroom, even under the code, allows just open the window and you can ventilate it out. But for normal bathrooms, like the one on the ground floor, yes, the mechanical ventilation. All public restrooms must have some kind of mechanical ventilation, etc., etc. All right, so mechanical ventilation is required for bathrooms and toilets and showers and tubs and etc. All right, enough of that. I'm not going to beat up on lighting. We covered that in CNBT 1311. We already talked about the number of foot candles required for an exit. But this does, the minimum for artificial lighting is 10-foot candles over the area of the room at a height of 30 inches. Again, we talked about light fall off from the height, right? So your light's going to have to be brighter. All right. And we've already talked about the 1-foot candle at the surface and that sort of thing. Courtyards have their own requirements. Your local building codes are going to govern this. Atriums, you name it, okay? And sound transmission. All right, that pretty much beats up chapter 12. You can go ahead and read down through this if you want. And access materials, again, surrounding materials also transmit sound. Sound design is also another, and sound abatement in habitable spaces is a specific specialty area. And it shouldn't come as a surprise that a hard surface tile wall is going to bounce sound more than softer material walls. All right, let's go on to chapter 13. Energy efficient. Chapter 13 is one page. The nuggets out of this are down here. Okay? If the IECC is to be enforced locally, then your local authorities must adopt it and include it in the IBC. Your local authorities must include the IECC in its local code, or it can't be enforced. Not all areas have the same energy requirement designs. Now, that should not come as a surprise. You're not going to have the same energy requirement design in Phoenix, Arizona, as you're going to have in Houston, Texas. A designer must check with the local authorities having jurisdiction for any local adoptions. So there are 3 elements in here, 1, 2, and 3. All right, that you must do. It's important to watch these videos. Okay. If you're going to adopt the IEC, if you're going to enforce the IECC, it must be adopted by the local codes. Not all areas have the same energy requirement designs, and a designer must check the local codes. Moving on to Chapter 14. All right. If you don't get anything out of this video for Chapter 14, you need to get these 5 points. The perfect wall, the perfect roof, the perfect slab, the perfect floor must protect against the transmission of the following: moisture, vapor, air, thermal, and sound. The perfect wall, roof, slab, floor must protect against the transmission of the following: moisture, vapor, air, thermal, and sound. It must protect against moisture, vapor, air, thermal, and sound. All right. All right. You have been warned. All right. This is kind of silly, but sometimes Ching does that. This section of the IBC requires an exterior wall envelope to protect the structural members of a building, including your framing, sheathing, as well as conditioned interior spaces from detrimental effects of the exterior environment. And what is that? That's this stuff up here, right? By definition, any exterior wall, bearing or non-bearing, is a plane with an angle of 60 degrees or greater with the horizontal plane. It's an exterior wall. Okay, great. I'm glad he put that in there. I sleep better at night knowing that, right? What a wall is. Okay. This talks about veneer facings and such as that. We go into weather protection and other requirements. If you just focus on these 5 points up here and make sure all of those units have that, you will be good. All right. All right. Climate zones. The U.S. climate zones are broken down by county. They range from extremely hot and dry. The bottom line is there are 8 major zones in the United States, as you can see by the map. Now, we live in Zone 2 here on the Gulf Coast, the third coast, right? Very hot, very humid. All right. Oh. Again, we live in Zone 2 of the 8. Vapor retarders. There are 3 classes of vapor retarders. You can read this stuff here. Some are good, some are less than good. These are your official vapor retarders. Class 1, Class 2, Class 3. There are 3 classes of those. All right. And here's some vapor retarder options, depending on your climate zone. All right. All right. Some examples, detailed examples. right, what's the nuggets out of this? It's flashing, 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 and more flashing, flashing, flashing. This section of the code requires the installation of flashing to prevent moisture from entering at locations such as those illustrated to the right. That would be over here. The intent of the list that contains examples, not just the conditions to be satisfied, is that flashing be provided at any condition where it would prevent moisture from entering the structure. Flashing also prevents the intrusion of raccoons, mice, and rats, all right, as well as moisture. Okay, so why do we require flashing? To seal off moisture intrusion. You get 125-mile-an-hour rain like we got last week here in Houston. It tore everything up. You got driving rain, so do not skimp on your flashing details. There is a old saying in engineering and architectural design that the devil is in the details. You screw these details up after it's built, it is awful hard to go back and retrofit and try to fix a poor design flash system. If you took my Cnbt 13, oh my God, what is it, 14 or 11? Anyway, construction materials and methods. You'll know that I have a real pet peeve about this. The Cypress Center, the RTUs, the rooftop units, they leak like a sieve because they poured the whole upper deck and then they went in and cut holes and then set the dog houses, the curbs on top of that, and tried to flash them. They leak all the time. Dumb design. Wood veneers. Wood veneers. You put wood veneer on my house and I'm going to fire you. If you took my CNBT 1311 class, construction materials and methods, you'll know that I do not like wood siding or cedar shake. Why don't you just burn your house down before you build it? Anchored masonry veneer, we discussed that in the other CNBT class. Adhered masonry veneer, I'm not a big proponent for this because you're asking that stuff to stay up there glued or adhered. If you're going to go to the expense of masonry, use masonry or tilt wall concrete. Metal veneers. Metal veneers must be of non-corrosive materials. Anti-corrosive coatings, whether it's galvalume and then it's painted, or it's aluminum that's anodized. Back in years ago, there was companies that tried to sell vinyl siding to go over your old wood siding. Boy, that was a boondoggle. There's no amount of UV inhibitors that's going to make vinyl siding last the life cycle of the structure. Plus, vinyl siding, after it gets in the heat down here, it gets brittle, and then it gets punctured easy. It's just a bad design. Don't use vinyl siding. You can use metal, engineered metal that's like galvalume, which is aluminum and galvanized. We talked about that in the other CNBT course. Fiber cement siding. What is fiber cement siding? AKA Hardy, James Hardy. I love this stuff. It needs to have a hard backer behind it because it's brittle, it's cement board, but it'll last forever. You can paint it, you can get it in all kinds of different shapes and sizes, and if you go to the James Hardy website, they have AutoCAD files you can download in details on how to actually install this stuff properly, detail it properly, flash it properly, and it is a good material and will last a long time. Now, it is not asbestos fiber. You may have an old house that's got old asbestos siding on it, and the best thing to do is cover it over. If you start removing it, you're going to have to get asbestos remediation. Best thing to do is just cover it over with hardy plank, hardy siding. And you can get this stuff in 4x8 foot sheets. You can get it in shiplap. You can get it, and like I said, you just go out to the Hardy website, James Hardy website, and they've got details out to Wazuli for you to download and use. All right, enough of that. So is fiber cement siding allowed? The answer is yes, it is. Fire blocking. If you took my other class before this one, well, you should have taken it before this, and that's a prerequisite. But nonetheless, fire blocking is extremely important. It does two things. It does what it says it does. It's a quote-unquote fire block, but it also strengthens your stud wall. It decreases the L over R ratio. Now, that's structural engineering geek speak for making the column of the 2x4 stud or the 2x6 stud less. So let's just say this is the stud, this is the seal plate down here where it sets. All right, and this is a double top plate, the double top plate. All right, let's say this is an 8-foot stud. Well, if you come in and put fire blocking at 4 feet, in between the next stud, and the fire blocking is going to be offset. If you've ever done any framing, you'll stagger them like this, and then the next one will be down lower, so you can actually get your nail gun in there and nail it from the sides. And that one's there. Okay. So now you have a stud or a column that's not 8 feet. It's 4 feet. In this example, it would be 4 feet here and 4 feet here. It's not 8 feet. Now it's a stiffer column. And this might be, this is 1.5 inches, so you'd offset this maybe a couple of inches. So this is going to be 4 feet plus, and this is 4 foot minus, but it all averages out to 4 feet. So now you've got a column that's half the length, and it'll carry more load. It'll also be more resistant to shear loading coming in this direction. But because we're worried about fire, what does this do? You get a fire down here. Maybe the fire load is down here. All right, let's put the little fire gizmo. Fire, oh no, it's burning. Okay, and we have a penetration here, and it finally comes. It keeps the smoke in the chimney and the hot gases from cycling up through this narrow wall cavity, because it blocks it. It gets blocked. It gets blocked right here. So it can't travel up here and create a Venturi effect and increase the velocity of the hot gases, which will increase the temperature of the hot gases and make the fire in the wall hotter than the fire out here. That's what fire blocking does. So, when is it recommended to be used? To me, everywhere, all the time. Okay? But the official answer in here is what? Anytime it's feasible. Well, you better check your bloody code, okay? It's not required where the exterior wall covering is installed over non-combustible framing. Well, if you're framing in my job, let me explain something to you. You better have fire blocking, and that includes light gauge steel studs, or anything else. I don't care. You need fire blocking. You better check your local code, and you're going to find they're going to want it. All right. But the official answer is anytime it's feasible. And this is where Ching and I disagree. All right. So Uncle Mikey says all the time. Ching says when it's feasible, but you better check your code. You better check your code. All right. Enough of that. Let's move on to chapter 15. This talks about metal composite materials, high pressure laminate systems. We're getting into some high-tech stuff here. And you check your manufacturer on its fire rating and their required detailing. All right. Roof assemblies and rooftop structures. How much time we got? We're fine. All right. All right. There are 5 major things we want to cover in chapter 15. Roof drainage. Roof drainage. It is governed by the International Plumbing Code. It's governed by the International Plumbing Code. The minimum slope allowable for coal tar built-up roofs can be installed with a slope of 1 1/8 in 12-inch vertical. That's a 1% slope. I recommend, and if you do me a building and design it with a 1 1/8, I'm going to fire you. The minimum down here has got to be, absolute got to be, at least a 1/4 in 12 or a 2% slope. You better check your local codes because we get a lot of rain. Most of your streets are only designed for 1 inch to 1.5 inches an hour rain. After that, things start to pond and flood. One of the engineering buildings that I used to work in had a roof collapse during a heavy rain because the roof drains up here got plugged up and it ponded and it collapsed. Pulled the joist right off the structural stuff. Really nasty job. Nasty, nasty, nasty. So, recommended slope. Recommended is this. Stay away from 1 1/8. Quarter per 12. Or 2% slope. All right. This talks more about performance requirements, foot traffic, and Cnbt 1311. We talked about some, they won't let you walk on the roof membrane. They've got walk paths up there. They won't even let you take the RTU unit off, set it off on plywood. It has to be a lift off and then a lift on. And we talked about that. Wind resistant, aggregate surface roofs. We talked about that in CNBT 1311. Now, a lot of places now, they don't let you put aggregate built up roofs because 125 mile an hour, 150 mile an hour hurricane force winds come in. They pick that stuff and start stripping that aggregate off the roof. Pick it up and throw it into the building next door. It's like buckshot. Blows windows out. This talks about exposure category. Reflects out ground surface. Irregularities affect the wind pressure. Your structural engineer and your planners will help you with that. Okay. Wind design for structural engineering is funny. It depends on the geometry of the building, and not just the building you're designing, but the buildings around it. So that little narrow space there, you get a 125 mile an hour wind hitting this area from your screen view. This velocity in here is going to be a lot greater than 125 miles an hour. It's called the Venturi effect. All right, fire classifications. All right. Fire classifications. We have this section of the IBC divides roofing assemblies into fire classifications A, B, C, and non-classified. There are 4 fire classifications. 4. Okay? 4. A, B, C, and non-classified. Class A, B, or C must be approved by the building official. Ratings are determined based on the performance of the roof coverings and the fire test of what you're doing, what you're putting up there. Okay? So, there are 4 fire classifications: A, B, C, and non-classified. All right. Let's move on. Asphalt shingles. The minimum slope for asphalt shingles is what? Oh my goodness, it's right here. Asphalt shingles. Minimum slope. Minimum slope is 2 on 12. For slopes over 4 on 12, a single layer of underlayment is acceptable. Do not skimp on your underlayment nor your flashing. But the minimum roof slope for asphalt shingles is 2 on 12. And why is that? You get flatter than this, it starts considered a flat roof, and you're going to have water mitigation back up underneath your shingles. That water velocity is going to be so slow it'll start ponding. Because trust me, that underlayment's not going to be exactly horizontal. You'll have water flow going back up underneath here, and you don't want that. You don't want that at all. All right. So the minimum slope for asphalt shingles is what again? It's 2 on 12. All right. This talks more about asphalt shingles. There's a valley. Here's your flashing. Do not skimp on the flashing. My God. You screw up your flashing detail after it's built and you get water pushing back up through this building, you're going to have a pissed off client. And it's going to be awfully hard to fix it after the fact. Crickets, that's water sloping down to hit a chimney structure. This is a water diversion, basically is all it is. All right. Metal roof panels, the best thing for you to do is get with a good metal roofing company. There are some good YouTube channels you can subscribe to. If you took my other CNBT class, those were referenced to you. These people are in the business of staying in business, and they want you to use their metal roofs. Metal roofs are great. They're more expensive than asphalt at times, but a properly detailed and done metal roof will last longer than an asphalt shingle. And Matt Reasoner's got some interesting details on how to put in metal roofs to allow the air to flow between your underlayment and the metal roof and keeps your house cooler. All right. Wood shingles, I'll fire you if you put wood shingles on my project. Ain't going to happen. Not going to happen. I don't care how quaint and pretty it looks. Okay? Go ahead and burn your house down before you move into it. Built-up roofs. You can spend a whole semester studying all kinds of built-up roofs and membrane roofs and stuff like that. Again, this is future problems for your next-door neighbors. You got high impact winds. The stuff gets old. The gravel gets loose, and boom, it just gets picked up and thrown like buckshot. Sprayed polyethylene foam roofing. In my CNBT class, we talked about sprayed domes, and the sprayed dome structures of the Monolithic Dome Institute up in Little Italy, Texas. You can get on the website if you haven't taken my CNBT 1311 class, and those things are pretty much bulletproof structures. Tornadoes, fires, you name it, they survive really, really well. All right. Penthouses. There are 4 types of penthouses. Rooftop structures include such items as penthouses for elevators, water tanks, cooling towers, and spires. There's 4 of them in there. The 4 types of penthouses: elevators, water tanks, cooling towers, and spires. Talks about dormers. We went through that in CNBT 1311, and that sort of thing. All right, that ends week 3. We're at 55 minutes. That's not bad. Not bad at all. If you followed through this video with the test already printed like I have stated before, then you have answered your questions by the time we get to the end of this video. Merry Christmas. I've tried to make this class as painless as possible. All right. We're at week 3, finished week 3. You should have an A on this test. All right. We'll see you on the next video.